geologic history. Some units don't use the reference table at all. Some use it a lot. This one uses it a lot. Specifically, what I like to call the centerfold of the reference table. Pages 8 and 9. There's so much on here. Oh my goodness. Now, it is important to be familiar with this. I'm going to use this analogy. It's like trying to cook a full Thanksgiving dinner and dessert in someone else's kitchen. Okay? In your own kitchen, you know where every measuring cup and every serving bowl and spoon is. And it's not that difficult, but in someone else's kitchen, you don't know where anything is. It's very confusing, okay? You want to be familiar with this like it's your own kitchen cabinets. Know where everything is so you can find it, because if you're not familiar with this, you can't use it to answer a lot of questions. So I'm warning you now. So here we go. Let's start with some basic things. Earth and our solar system is 4.6 billion years old. I would love for you to know that in your head, but you don't need to have it in your head. I'm telling you that now. It is on the reference table. Here we go. So here is the centerfold here. Okay, here's a big section of it, and now I'm going to zoom in to just this side, and this is sort of the timeline of Earth, and we're going to kind of zoom into the bottom here. Now, and so this is the very bottom, and this is all millions of years ago, and so it's 4,600 million years ago, and that equals 4.6 billion years. So you can look that up. They have it listed like this, but that is where you can reference it if it comes up. So that's nice that's on there. This is a question from an old exam. On the timeline below, which letter represents the origin of humans? Okay, so this is today, down this dot here, all the way down there's the origin of Earth. This is all of Earth's history. Which one is when humans first came on Earth? I'll tell you the answer right now. It's D. Notice, right towards the end, all that time without humans on Earth. Love it. Crazy, mind-blowing. Now, how can you know this? It is on the reference table, so that's nice. I'm going to show you how to find it. Some of the stuff is it's a little convoluted. So in the red here, this shows the basic timeline, all of Earth, from when it started to today. So this is all of it right along here. Now, this section here, the last 550 million years, so much went on Earth as far as evolution, life changing, all the different life forms went on here, that we can't write it that small. So they expanded it out to be all of this. So all of this here equals this segment in time in Earth's history. Now, let's find humans on there. And this is where being familiar with this helps. Humans is right up here. So of all the yellows at the very, very top, so humans would be like right there. Right there. So basically, humans have existed for such a short percentage of Earth's history. It's totally cool, and it's a point that I want you to get, and New York State wants you to get. So that's why we see questions like this. This was a multiple choice, and this was the correct answer. If the pie graph, the complete pie graph, is all of Earth's history, what segment of it have humans existed? And it's that. It may even be smaller than that, but it's really small. That's the key. So be on top of that. Here is another question, and here's a diagram from it. And it's basically the origin of Earth's early atmosphere is volcanic eruption. So that's not actually a question yet, but basically there were so many volcanic eruptions, so much volcanic activity in really early Earth. The first 2 billion years of Earth, and that's what created the atmosphere. All of the gases in the lava itself were going out in the atmosphere. So here it's showing water vapor, it's showing nitrogen, and it's showing what they're calling gas X, as an unknown. Because the question here was, what is gas X? Now, many people want to say oxygen, but it is not oxygen. It is carbon dioxide, okay? So this is early Earth with water vapor, nitrogen, and carbon dioxide. Oxygen would come later, and sometimes we see questions like this. What is the source of atmospheric oxygen on Earth? Well, we can look that up. That is in the reference table, but you have to know where to find it. It is the photosynthesis by early plant life. Okay, plants, as part of photosynthesis, they take in carbon dioxide, they give off oxygen, and that's how it gets into the air. So let's see where that's on it. This is the centerfold of the reference table. We're going to zoom into this area here, and we're going to look at it closely. So, in this area of 2.5 to 3 billion years ago, it says oceanic oxygen produced by cyanobacteria combines with iron, forming iron oxide layers on the ocean floor. Okay, so that's the first oxygen in the ocean. And then you're talking about oxygen in the atmosphere. That's up here. Oceanic oxygen begins to enter the atmosphere, somewhere around 2.2 2 billion, 2.3 billion years ago. So know that that's where you can reference it. I will admit, it is hard to find this stuff. It's so small, it's all over the place. And if you're looking at it for the first time, you're not going to find it. So hopefully you have some experience looking these things up. So here's a question. Most of the oceanic oxygen that began to enter Earth's atmosphere in the early Proterozoic era was probably produced by photosynthesis by cyanobacteria. Know it.